Dear students, today now we'll do topic 4.17 in chapter Pressure in Fluids, and the topic is calculating an equivalent height if water is used as barometric liquid. Means in place of mercury, if we are making water barometer, then in water barometer, what can be the height of water in the barometric tube which can balance the atmospheric pressure? So that height we have to calculate in this topic. And see, this is the thing which you have to understand nicely, and it is, see, I have shown here two barometers. One, this is water barometer. It is made with water. Inside the barometric tube, water is taken. Trough is also that of water. And if you make this, then certain height of water from here to here will balance the atmospheric pressure outside. And we don't know this height. Although we know the density of water, but we don't know the height of water column in barometer which can balance the atmospheric pressure. That is equivalent height in a way. And I have also shown mercury barometer here. And you know, at sea level, 76 centimeter of height of mercury in the barometric tube supports atmospheric pressure. And both these barometers are at same place, so naturally atmospheric pressure is same. Now, in water barometer, what will be the atmospheric pressure? Will be given by HW height of water in the barometer. So whatever pressure is applied by HW height of water in the barometer, same is the pressure outside. Okay, same is the pressure outside. Now, of the atmosphere. So, what is the pressure exerted by HW height of water barometer? It is H rho G, HW rho W into G. So, this is the pressure exerted by HW height of barometer, and that is equivalent to atmospheric pressure outside. In mercury barometer now, how you will get the pressure, atmospheric pressure? Atmospheric pressure will be equal to the pressure exerted by 76 centimeter of mercury level, and suppose this height is H mercury. So again formula is H rho G, but here height of mercury into density of mercury into G. And this equation also gives us atmospheric pressure. And because atmospheric pressure outside is same, therefore equation 1 and 2 we can equate. Means right side we can equate. HW into rho W into G is equal to H mercury rho mercury G. W for water, Hg for mercury, you know that. Now G is common, we cancel and we get HW. So HW is equal to H mercury into rho mercury divided by rho water, density of water. And we put the values. We know height of density of mercury is 13.6 and height of mercury is 76 centimeter in CGS system, divided by density of water in CGS system is 1 gram per centimeter cube. And you multiply 13.6 into 76, you will get 1033.6 centimeter, right? Equal to, now you convert it into meters, equal to 10.34 meter. It means in case of water, 10.34 meter height of water will balance atmospheric pressure. Means 10.34 meter of water level here will exert as much pressure as is exerted by atmosphere. I hope it is very clear to you. Okay, this is how we get the equivalent height of water barometer, right? Now, for article 4.18, reason for using mercury as barometric liquid. See, first point is vapor pressure of mercury at ordinary temperature is almost negligible. Vapor pressure means pressure exerted by vapors of mercury. Means under ordinary temperature, vapors of mercury are formed but very less, negligible, and it does not evaporate. Almost no evaporation is there under vacuum condition. Hence the mercury column in the barometer represents the true atmospheric pressure. Before you understand this topic, I'll tell you something else. Suppose this is a liquid, okay, some liquid is there in the vessel, some molecules are inside. The molecules which are in the bulk of the liquid, they are attracted in all direction, and that is because of intermolecular force. And those molecules which reach the surface, they are attracted downward or sideways only, not upward, because in the upper part there is no liquid here. So how they can be attracted upward if no liquid? Intermolecular forces are acting downward only. And because of this the downward attraction, it results in another property of liquid, that is surface tension. So the surface behaves like a stretched membrane. In any molecule striking the surface is pulled down. It is pushed down because of surface tension. And if the molecule, molecules are striking with one another and then they keep on gaining kinetic energy. When other molecules strike, one molecule strike another one, then one molecule may hand over energy to the next molecule. This way, some lucky ones, their kinetic energy goes on increasing. And then they can overcome intermolecular force and can overcome surface tension also, depending upon their energy. Then they have to overcome atmospheric pressure, because we know atmospheric pressure always pushes everything down, on the surface downward, right? So atmospheric pressure also has to be overcome. So three forces if are overcome by the molecules of liquid, then they can escape, means evaporate. Right? But out of these three forces, if one is absent, atmospheric pressure is not there, means vacuum is there, then naturally evaporation becomes little easier, because one less force now has to be overcome. Clear? So that's why they are saying the mercury does not evaporate under vacuum condition also. Why? Because the intermolecular forces in mercury molecules are very large. This is very large. So even if atmospheric pressure is absent, then also the evaporation of mercury is negligible because of large intermolecular forces. And that's why they are writing it does not evaporate. Almost negligible evaporation is there. Suppose, if any liquid evaporates, say this water evaporates, then water vapors will be collected here in the upper part, right here, and those water vapor will apply pressure and push the level of water down. Clear? And this is a new level. This level is not because of atmospheric pressure. It is because of the pressure exerted by water vapors which are collected here. But in case of mercury, because mercury does not evaporate under vacuum condition, here torricellian vacuum is there, does not evaporate, so naturally if vapors are not there, then the level of mercury is not pushed down. And hence this barometric height will give true barometric pressure. Do you understand? Okay, this is the topic. And what is the material in it? Because mercury have low barometer, low vapor pressure, therefore it is a good barometric liquid. Okay, I have explained the reason for you. Secondly, density of mercury is very high, 13.6, very high, and that of water is just 1 gram per centimeter cube. This is very high, and therefore a very small height of mercury, see that only 76 centimeter of mercury height will apply enough pressure to counterbalance the atmospheric pressure. But in case of water, what is the height of water column required? Not centimeter, 10.34 meter. And this is impractical. Okay, 10.34 meter. This is impractical. But 76 centimeter, it is practical height. We can easily manage this. But this is very difficult to manage. Right? So in case of water, the height is disadvantage, but in case of mercury, it is advantage. And why this height is less and here more? Because density of mercury is very high, and denser liquid apply more pressure. That is why lesser height of mercury can apply enough pressure to compensate atmospheric pressure. Right? So here low vapor pressure is advantage for mercury, but in case of water, vapor pressure is not low, very high. So that becomes a disadvantage for water, but advantage for mercury. Low pressure is advantage for mercury, but water have high vapor pressure, so that is disadvantage of water as barometric liquid. Now density of mercury is 13.6. This is advantage. That's why only 76 centimeter height of mercury can support atmospheric pressure. But in case of water, density is just 1 gram per centimeter cube. So height of water column required to compensate barometric height is very large. That is 10.34 meter. That is impractical. So two advantages of mercury as barometric liquid. At the same time, we have done two disadvantages of water as barometric liquid. Next is mercury can be easily obtained in pure state. Mercury can be obtained in pure state. Hence, it can record true barometric. The atmospheric pressure also. Barometric height is true. Therefore, atmospheric pressure is also true. Clear? But water is a universal solvent. Water is a universal solvent, and therefore water is not available easily in pure state. Even if it is pure, then it can dissolve air in it. It can dissolve glass in it. It can dissolve any vessel in which it is kept. Clear? So for water, it is disadvantage. Third is mercury is an opaque shining liquid, and therefore in barometric tube, glass tube, the level of mercury can be easily identified, easily seen. So that is also advantage. But water is as transparent as glass. Therefore, it is difficult to see the level of water in glass. Water is also transparent, glass is also transparent. Therefore, it is difficult to see the level of water in glass tube. So that is disadvantage for water, but advantage for mercury. And next is mercury does not wet the sides. Therefore, it gives a correct reading. But water wet the sides of the vessel in which it is kept. Hence, reading given by water barometer is not highly correct one. So advantage of mercury, if because of certain properties. Water have opposite properties to that of mercury. So all those points are therefore disadvantage for water. Clear? Now see, water barometer will support 10.34 meter. This is impractical, one disadvantage. Water vaporizes under vacuum condition. That is also disadvantage. Therefore, reading given by water barometer is not a true one. Water is transparent, so it is not easily visible. water stick to the sides, therefore it will give an incorrect reading. Right? So always do these two topics together. Now, defects of simple barometer. See, in the simple barometer, you see simple barometer, this mercury in the bowl is exposed to air outside, exposed to air, and therefore impurities can enter. Even moisture also can enter, or other impurities also can, by accident they can enter mercury. So free surface of mercury in the bowl does not coincide with the first impurities will enter. Right? One point is this. And another point is this one: free surface of mercury in the bowl does not coincide with the zero mark of the scale fixed to the barometric tube, because mercury level in the bowl changes with the change in the atmospheric pressure as the mercury level inside the tube rises or falls. Thus, to get the correct reading, either the tube or the bowl will have to be moved up and down so as to make the zero reading coincide with the free level of mercury in the bowl. Now you try to understand this. See, if atmospheric pressure falls, because of season, temperature, humidity, pressure, okay, all these things, the atmosphere, because of altitude also, atmospheric pressure will fall outside. Right? When atmospheric pressure falls, the height of mercury in the barometric tube also falls. Height of mercury in the barometric tube also falls. Right? If height of mercury falls now, then mercury in the bowl becomes less because it comes down, and the mercury in the trough will increase. So therefore mercury level in the trough goes up, but the mercury level in the barometric tube reduces. Earlier zero on the barometric tube is here, zero is here. Okay, level of mercury is also here, but now level of mercury is here, but zero is still at the same place only. So what you have to do to match this zero and the level of mercury? Because if you are not matching, you will not get the correct vertical height. You have to match it. Okay, whenever we measure distance, we have to match the zero of one end of that object. Okay, zero on the scale, we have to match with one end of the object whose length we are finding. Right? So zero have to be matched, otherwise how we can find the height. So zero has to be matched, but here zero is not matched. So then how we can match it? Either you take this test tube little up, so that this zero of the barometer goes up and match with the level of mercury. This can be done. Or you can take the bowl down. When you bring the bowl down, little bit down, then the level naturally will come down and match with zero. So you have to do one out of these two activities. And don't forget, if you lift the tube little more or the bowl down, then maybe it is possible the tube is pushed up little more and whole of the liquid in the barometer will be in the bowl. Then it will not be a barometer, it will collapse. So we have to be very careful, because just tube is inside, it has to be inside. If it goes out, whole of the mercury will come down and be there in the bowl. So this problem is there. Now if the barometric atmospheric pressure increases, then this is normal barometric height. Now new barometric height will be more, because atmospheric pressure increases, so barometric height also will increase. Now more mercury is there in the barometric tube, and therefore mercury in the bowl will be less. See, it will come down, but zero is here. Again zero is not matching with the level of mercury. Then what we have to do? We have to either bring this tube inside, or we have to move the bowl up to match the zero. And if we are not matching the zero, so naturally then the true atmospheric pressure cannot be taken by barometer. And this is a very big problem issue. Maybe you can say, sir, it's very easy to take it up and down. So, it's an expert person is required to do this. It's not easy. And don't forget, even if 1 liter of mercury is there in the bowl and the barometric tube, its weight will be 13.6 kg. 1 liter of mercury in the bowl will have a very large amount of weight. So you have to be very careful. Mercury is very heavy liquid, right? So it's a tedious job, and that is the disadvantage of simple barometer. 1. Second, it is quite inconvenient to move it from one place to another. You see, 1 meter is quite a distance. 1 meter of barometric tube is suspended in mercury. And if you have to move it from one place to another place, and a little jerk somewhere here and there, what will happen? The whole mercury in the barometric tube will flow back into the trough, and the barometer will collapse. It will not be a barometer then. So again, moving it from one place to another is not convenient, because mercury may spill over, right? Third point, it is quite difficult to keep the barometer tube in vertical position. See, if you have to make a vertical line, it's not easy. Maybe you can see that this line which I have drawn is perfectly vertical, but actually maybe slight difference is there. And slight difference in vertical position, if the position is not perfectly vertical, so naturally barometric height will also be more. If it is vertical, then barometric height will be exact. If it is not vertical, tilted one is there, so then barometric height naturally will be more only. Clear? So it's difficult to keep it perfectly vertical. Next one, there is no protection provided to the glass tube. See, protection is not there. It's a glass tube, very thin glass tube only. If somebody by accident, something hit with it by accident, so this tube may break. Break means the barometer will be broken, nothing will be there. So protection is also not there. Last one, since mercury is exposed to air, this we have done earlier. Since mercury is not exposed to air, there are chances, there are impurities, maybe moisture, maybe other metals. Okay, they may enter the mercury from the top. From here, impurities may enter. And if impurities are there, we have already discussed, if moisture is present in the barometer, it will give a wrong height. Yesterday I have discussed with you here factors. And if metals enter, then that also will make the barometer unfit for taking correct readings. So these are the disadvantage of this simple barometer. Dear students, now this is Fortin barometer. See, in the earlier we have done this disadvantage, defects of simple barometer. So these defects which we have discussed here are overcome in Fortin's barometer. Now what is special about this barometer? See, in simple barometer there is a bowl which have a solid base, but here what is taken, one bowl is taken here, this part, right? This part I'm just you see clearly. See, this part is made up of leather. Bottom of the vessel is made up of leather, and then brass is there. Brass cylinder is there. So very long brass cylinder up to here, and certain holes are here, and in the middle one slit is cut. Brass slit part is cut here in the middle, right? This brass part is cut, and glass is put here, glass in place, so that we can see the barometric height inside it, right? Now this part is a leather means bottom is loose. Now it's a loose bottom. In brass cylinder it is fitted, right? And here mercury is put, right? And below this bag there is zero adjustment screw. If you move this zero adjustment screw up, then the mercury level will move up. If you move the screw down by operating it, the mercury level in the barometric tube, this level will come down. If you move it up, this level will go up. If you move it down, this level will come down. Clear? So by this method, by just moving zero adjustment screw, we can easily match zero of the barometric tube with the level of mercury. Okay, we can match these two, and matching the zero of the barometric tube with the level of mercury is very important. Then only we will get a correct height. Clear? One thing is this. Secondly, just above here you see brass cap is there. With the lower end of the brass cap there is ivory pointer. Very light material is used here as a pointer. And this pointer just touches the level of mercury. When the pointer just touches the level of mercury, means zero of the barometric tube is matched with the level of mercury. Right? And there is a hole here, air hole. This hole allows the air to come in. When air comes inside, then only it will apply barometric pressure on mercury. Then only we can measure the atmospheric pressure by this Fortin's barometer. Clear? And you see, now this barometric tube is a very long one, and at the top here, with the help of cork, it is fixed here so that it should not move here and there in the brass tube, right? And then a suspension point is also, hook is also provided to hang it. In the middle somewhere here you see this full tube is actually brass, but here only, this part only is cut, brass piece is cut, and glass is fixed there so that we can see inside where is the level of mercury. Then main scale is provided on this glass piece, on the brass but pointing towards glass piece. Main scale is provided, and inside there is a vernier scale also, which can move on the barometric tube, move up and down. By moving the vernier scale, vernier scale is provided to have more accuracy while taking reading. So vernier scale is also provided so as to have more accuracy, right? That is also provided here. And for a vernier adjustment, there is adjustment screw also. We can move this vernier scale up and down with the help of adjustment screw. Okay, so see, what were the defects earlier we have discussed? It is difficult to match the free level of mercury. Now that is over because adjustment screw is there at the bottom. One, it is quite inconvenient to move it. This you can move quite easily, not very easily, but quite easily you can move it without a fear of the spilling over the mercury. It is difficult to keep it in vertical position, but the Fortin barometer you can put with the wall in vertical position for once and all. Next time no need to change. There is no protection to the glass in a simple barometer, but now brass tube is protecting the glass tube, barometric tube. Right? Here mercury, in the mercury which is exposed to air, no, in the simple barometer, mercury is exposed to air. So impurities can enter. But in case of Fortin barometer, mercury is not exposed to air very much. Only when you have to take a reading, then only this hole is opened, air enters, and we take reading and then we close the hole. So chances of entry of impurities are very less. Clear? So this way, Fortin barometer is a little better. Those disadvantages are removed somewhat. Now how it works? In order to record barometric pressure, first of all, zero adjustment screw is moved up. This zero adjustment screw is moved up and down so that the edge of the pointer meet the level of mercury. First thing to do. Okay. Now vernier scale is moved up and down so that vernier scale just coincide with the level of convex level of mercury. because mercury is its topmost level is not flat, it is convex, so it should match with that. So that is done, and then by using vernier scale and main scale reading are taken, then we use those two readings to get highly accurate reading. And there is no fear of that the position of the barometer is vertical or not, because it is already fixed there on the wall in vertical position, and whole of this arrangement is put in a glass box fixed there. So, and then only it is put with the wall once and for all in vertical position, then afterwards no problem will arise. So this is Fortin's barometer. Now next one is Aneroid barometer. Aneroid means dry, so it has no liquid, so dry barometer only. It is highly portable and can be fixed in any plane. That one, Fortin barometer and simple barometer, both are placed in vertical position, but Aneroid barometer can be placed in any position. And construction now. Construction. See, it has this corrugated iron box. Corrugated means sides are very loose sides, and like this paper I just have shown just try to make you understand. This is a paper, I just bend the paper and it is moving like this. So those very thin sheet of iron is taken and it is converted into like this, bends are there. See, I just bend like this, so that the movement becomes easy, means the box can be compressed or stretched easily. If it is a very straight wall like this, wall of the vessel, then how you can move it? You can't move it. If it is a straight wall, how can you move it? It's very difficult to move. So the sides of the vessel are corrugated. Corrugated iron bends are there in the iron sheet, and those bends are used, that type of iron sheet is used to make this box. And inside this box there is air at a pressure slightly less than atmospheric pressure. Okay, already some air is there inside it, and just above that there is one needle. C is there, it is fixed, middle diaphragm is fixed. See, it consists of partially evacuated box, B, corrugated box, then which acts as a diaphragm. That box acts as a diaphragm only, diaphragm. It is fixed at the base of a circular wooden box. At the bottom, circular wooden box is there. In the middle of the circular diaphragm is fixed a central lever which is connected to flat spring A and to the system of levers D, E and F. See, this C is there. C pointer is there. It is just touching the corrugated box here. And this C pointer is connected with the spring, fixed spring. And on the other hand, this C pointer is connected with the levers, D, E, F levers. What is the function of levers? They can multiply the force. Right? Then the flat spring protect the diaphragm from collapsing. What is the function of this flat spring A? It will doesn't allow the collapsing of this corrugated box, which act like a diaphragm. It will not collapse, means the pichkana nahi hai, right? Now the flat spring protect the diaphragm from collapsing, whereas system of lever help in magnifying any tiny movement of the central lever. The system of lever is further connected to metallic chain and pulley edge. See, the levers are connected with the chain. This is a chain, G chain is there, which moves over pulley edge. This also a part of the pulley only. Then pulley is connected with the hairline spring, very thin spring, K. And then it is connected with this needle. And needle moves over a scale. So this is the construction. Right? Now how it works? Working. Suppose the atmospheric pressure increases. This increases the pressure, pushes the diaphragm downward, on account of which central lever moves down. See, if pressure of air increases, then this corrugated box will be pressed down. because if some pressure, if you apply more pressure of anything, it goes down, pressed. So when it is pressed, then this C pointer C, it will move. This pointer C will move. So motion is there in the pointer C, and that motion in the pointer C is multiplied by these levers. Means little motion is magnified, and because of that motion, this chain is pulled back, or for it is either it is pulled or it is released. Two things can happen, right? Then this pulley moves. When this pulley moves, needle is attached with the pulley, and the needle moves on the scale, and the needle will stop somewhere on the scale, and wherever it stops, from there we can take the reading of the atmospheric pressure. Clear? So it is so simple. Like this we can take. And when pressure falls, the pressure will not be same always. Pressure can fall also. When the pressure falls, then this spring, when the needle moves, the spring also wind up. So it develops restoring force in it. When pressure decreases, this spring brings the needle back to its original position. So that is the function of this hairline spring. And this full arrangement, beta, is kept in a small box, a watch-like box. Right? And you can keep it anywhere. You can take to any place. You can keep it any plane also. So it is highly portable one. And when you have to use, then only you have to open one. One hole is provided. You open it. Air enters. You take the reading of the pressure, and then again close it. So it's like a watch. It's an instrument like a small watch, and can be used. Right? But Aneroid barometer is not highly accurate one. Highly accurate one is this simple barometer. Accuracy is more here, but using it needs a lot of expertise. Right? Now some disadvantages also are there in case of advantages of Aneroid barometer are also there. Disadvantage, I have already told you, it is not highly accurate. Disadvantage already given. Advantage, does not contain any liquid, so there is no problems related to liquid. Right? See that in factors which affect the barometric height, moisture is impurity. It is a problem of mercury only, because mercury can absorb moisture. Impurities, liquid is there, so impurities will be there, and metals are also there as impurity. So these are the problems related with the liquid, but here no liquid. If liquid is not there, there is no such problem related to liquid. Secondly, it is free from the defects caused by impure or moist mercury. Impure mercury, moist mercury can affect the reading, but there is no liquid. Okay, so no such problem. And liquid is not there, it will not spill over also, so no such problem. Third one, it is compact and portable. It is compact, small one, very portable. You can keep it in any position. There is no need to keep it in vertical position also. Right? So that is also advantage. And the fourth one is, it can be fixed in any plane. I have already told you, no need to fix it in upright position, only vertical position. You can place it in any place, any position. So it will work nicely. Right? Next topic, beta, it is effect of height on barometric pressure. Effect of height on barometric pressure. This topic you have to understand.